In previous lectures, we used for loops to pass over the characters of strings and the items in lists. In this lecture, we are going to use for loops to pass over the indices of strings and lists, and this will allow us to solve problems that we can't currently solve using for loops. The first problem that we'll tackle is to count the number of neighboring pairs of characters that are the same within a string. So here's an example string. And in this string, there are 3 pairs of neighboring characters that are the same: the C's, the F's, and the G's. In order to solve this problem, we need to compare neighboring pairs of characters. So the string at index 0 needs to be compared with the string at index 1. The string at index 1 must be compared with the string at index 2. And so on until we reach the second last character, the string at index -2, and we compare it with the last character of the string at index -1. Generally speaking, we can describe this as comparing the string at index I with the string at index I plus 1. We'll use the range function to generate these numbers: 0, 1, up to and including -2. So the I values in our comparison. As a reminder, range has 3 parameters, 1 required and 2 optional. The required parameter is the value at which we want to stop the sequence, and optionally we can also provide the start and the step. In this case, the start we want is 0, which is the default, and the step is 1, which is also the default. So we only need to use the stop. And we want to stop at the length of the string -1. In other words, we want to go up to and including length of the string -2, or the second last character of the string. And we indicate this using length of string -1, up to but not including that value. And then the values, or the indices, are printed. Now that we've written this for loop, we're going to use the same header in our function to count the repeated pairs of characters in the string. The function that we're writing is count adjacent repeats. It has a single string parameter and returns an int. And when we call the function passing the example string as an argument, the function should return 3. For this function, we need to keep track of how many repeated characters we've seen. So I'm going to use a variable named repeats to do that, and repeats will have an initial value of 0. We want to go over the characters of the string, pass over them, and we need to use their indices this time. We wrote this for loop header already. We're starting at index 0 and going up to the second last character of the string. In the body of the for loop, we want to compare the character at position s at index I with the one that comes after it to see whether they are equal. So we can use the equality operator for this, comparing s at index I with s at index I plus 1. When they are equal, we found one of these adjacent repeats, so the repeats variable should be increased by 1. At the end of the loop, after it has exited, we can return the value that repeats refers to. Finally, let's just run this function call to ensure that it's working as expected. To do that, I need to execute or run the module. And now we can call the function, and it returns 3 as expected. So to summarize, it's because of the fact that we want to compare an element of the list with another element in the list that we are using the indices. It's not enough to know what the value of the item is. We need to know where the item is in the list in order to determine which other element to compare it with. To gain a better understanding of what's happening when this code executes, we'll trace it using the Python visualizer. The first time I hit forward, the function definition is evaluated, and we're taken to line 19, where I've put a call to the function using a slightly smaller example. When the function is called, the parameter s refers to the string ACCFFH, which we passed as an argument to the function. After line 11 has executed, repeats refers to the value 0. On line 13 is the first line of the for loop. I will get the initial value of 0. I initially refers to 0. And the if condition is first checked. So s at I, s at 0 is A, is compared with s at I plus 1, s at 1, which is C. These characters are not equal, so the body of the for loop is not executed. We move on and increment I. So I gets the next value that range generates, which is 1. Now, I refers to 1, and s at 1 is compared with s at 2. Because the characters here are equal, the body of the if is executed, and repeats will be increased by 1. Repeats now refers to the value 1, and I gets the next value that range generates, which is 2. The string at index 2 is compared with the string at index 3, and they are not equal, so the body of the if is not executed. We advance to the for loop header again, and I will be the next value that range generates. I refers to 3. The string at index 3 is compared with the string at index 4. Those two characters are equal, so the body of the if is executed this time. Repeats is increased by 1, so repeats now refers to the value 2, and I advances to the next value, which is 4. The string at index 4 is not equal to the string at index 5, so the body of if won't be executed. And notice that this is the last pair of characters that we need to compare. So when the string at index -2, or the second last character of the string, is reached, that will be the last iteration of the for loop. We reach the header one more time, and there are no more numbers generated by range. So after this, Python advances to line 17. The value to be returned is the value of repeats, which is 2, and that is returned and then printed on line 19. Now let's write another function that involves looping over indices. This function is named shift_left. It has a single list parameter and modifies that list. So the return type is none type. None is returned. The modification to the list is that each element of the list, or each item, is shifted one position to the left, and the first item is shifted or moved to the last position. A precondition to this function is that the length of the list is at least 1. Here's an example list that has 4 strings, strings A, B, C, and D. The strings will be shifted to the left, moving B from index 1 to index 0, C from index 2 to index 1, D from index 3 to index 2, and A from 0 to the last position where D originally was. Therefore, the resulting list is B, C, D, and A. In the example, I showed moving B to the position that A was in, and then C to the position that B was originally in. One thing that I didn't explicitly show in the example is that when we move B into A's position, we need to keep track of A, what value is at index 0, in order to later be able to move that value to the last position in the list. The variable first item is what I'm going to use to keep track of this. So it gets the value at list index 0, and we will then be able to take the value from index 0 and put it in the last position later on. The task that we're doing is this shifting of items starting from 1. So I'm using range again. The first index that I will work with is index 1, and the stopping position is the length of the list. The task is that we would like to take the list at position I minus 1 and set it to the element to its right. So in other words, if 1 is the first value of I, we're going to take the list at position 0 and have it get the list at position 1. So once all of the elements have been shifted to the left, we then want to take the element that was originally in the first position and move it to the last. The last element of the list can be indicated using -1, and we will set that to our first item variable, which hung on to the original value at index 0. At this point, list L has been modified and the function can exit. Let's call the function. In the shell, I will create a list with the same example values that we used. We can call shift left, passing L as the argument. And now when we examine the contents of L, we see that the values have indeed been shifted to the left, with the first item being moved to the last position. We will once again use the Python visualizer to visualize the execution of this function call. This will help us gain a better understanding of the code, and it's something that you should be doing as you're writing your code. The function is first defined, and on line 17, the letters variable refers to a 4-element list of strings containing the strings A, B, C, and D. Now the function shift left is called. The function's parameter, L, refers to the list of strings that was passed as an argument to the function. On line 10, first item is a variable that gets the value of the list at index 0. First item refers to the string A. The for loop begins on line 12, and the initial value of I is 1. I refers to 1, the first value generated by range. In the body of the loop, the list at index 0, I minus 1, gets the value of the list at index 1. So list at 0 is currently A, the list at 1 is B, and we're about to assign the list at 0 the value of the list at 1. Now we can see that the list at 0 refers to B, and so does the list at index 1. That's why we use the first item variable to keep track of the value that was initially at list at index 0. We're going to need that later when we move the first item to the last position. Back to the loop, on line 12, the value of I will be increased. So I now refers to 2, and the list at index 1 will get the value that is currently at the list at index 2. List at 2 refers to C, and list at 1 is about to be assigned that memory address. So now both list at 1 and list at 2 refer to the C. I gets the next value, which is 3, and the list at index 2 is about to be assigned the list at index 3. So we have a list with B, C, D, D, and it's time to replace the last D with the A. That's what happens on line 15. The list at the last position will be assigned the value that was originally at index 0. This is the last line of our function call. So the function finishes executing and returns, then letters is printed. So notice that what was printed when the function returned was the value none. And now letters with the values with the strings B, C, D, and A is displayed.